Hey, and welcome back to another video in our Learning Java 2D Game Programming series. So in the last video, we did a lot of setup code for the AI state machine. So that means that now we can add states quite easily, and we can add transitions to those states. And today we'll be adding a wander state so that our NPC can walk around a little bit. As you can see down here in the console, he is currently transitioning from stand to stand to stand because it's the only state that we have. So let's change that. So go inside your AI state package and create your new wander state. This will of course extend AI state. Alt enter and implement these methods. So we're gonna need a few things. Let's start by getting a list of position, which we can call targets. And we had to also import the list. All right, let's just alt insert, make a constructor, but we don't want to take this list in. However, we would like to initialize it to an empty list. So target equals new array list. All right. We will get to the transition in a bit. Let's start here inside the update method. So what I'm thinking is that our wander state has to be able to pick new locations by itself. That's why I don't want to take anything in when we instantiate this. So we're just going to check here. If this is empty, then we obviously need to find a new target to move to. So the way that I think that we're going to do that, let's just ask it or check if targets is empty. Then we want to do targets.add. And we want to do state get random position. All right, so this does not exist yet, so we have to create it. Let's do it now. Create get random position inside of state, and our state will in turn ask our game map. Get random position. All right, so let's create that method inside of game map. So our game map knows a little bit more. We have the tiles, we know how large that is, and so what we want to do is let's get an X and let's make use of math.random. So math.random, which will give us a number between 0 and 1, a decimal number. So get math.random and multiply it by the tiles.length and also multiply it by the game.sprite size. And of course, sorry, we need to make that a double. Just duplicate that and do the same for y, except we have to look inside one of the rows of our tiles. And that will be it. So then just return a new position of X and Y. And right, we only have a constructor that takes an int, which is silly now that we actually have stored our X's and Y's as doubles. I still think we can keep it, but just say alt insert and generate a constructor that takes these in as doubles. So let's keep those both. If we go back here, it will be happy now. All right, so now we're back in wander and we've added a random position to our targets. And then let's ask it to, we need the controller now. So what we are going to do is let's get the controller from our current character. And it needs to be an NPC controller in this case, but we always know that our NPCs are going to be using an NPC controller. So let's just cast it. And if they don't, then this will throw an exception, which is fine because we wanted to use an NPC controller. So if for any reason our NPC is not using the controller, we have an error somewhere anyway. So current character get controller. We have not generated this getter yet, so Alt Enter, create method get controller, and the controller is inside the moving entity. So go here, make sure that it's a controller, and then return our controller. Go back to our wander. So now we have the controller. So we can say controller dot, and let's make a method called move to target. Let's first give it the target position, which of course is targets get 0. And then let's give it our current position, which is current character get position. All right, let's generate this method inside of the NPC controller. So let's call this target, and let's call this current. All right, so in here, we are going to do some things. The first thing that we want to do is we want to know the delta x and the delta y. So what is the difference between our target position and our current position? So let's get them first. Delta x, which would be target get x minus current get x. And the same for the y. So just duplicate that, Control D, and change all of these to y's. All right. Now, one more thing. Currently, we're just returning false, and that's not gonna fly. So let's make booleans. Let's make private boolean up and duplicate that. And I usually go in clockwise direction. So right, down, left. And I realize as I'm saying it that I didn't do that over here. Well, let's just fix that. So I just selected this and Control Shift moved with my arrow keys. So holding Control Shift and then using your arrow keys will move. It will do something called Smart Move. So you can just move like an entire method. Very handy. All right, now let's actually return these instead. Up, right, down, and left. All right. Now we need to set these to something meaningful. So let's get to it. So this is a little mapping, but it needs to be done. So let's do it. So the up is if the delta y is less than 0. That means we're going up. And the right is delta x is larger than 0. The down is delta y is larger than 0. And the left is delta x is smaller than 0. All right, that should do that. So we are in here, we're moving to the target, which is nice. But we also need to know if we have arrived. So if, and I'm gonna say arrived, right? And just gonna quickly check my notes. So yes, the NPC. Okay, and we need to create this. So let's do that inside of here. It said rename reference, which is not what I wanted. I wanted to make, for some reason, it doesn't understand that I want to make a method in here. So let's just make it manually. So private boolean arrived, and we take in the NPC, current character. Right, sorry, I know why. I wasn't supposed to do that. My mistake. There we go. All right. Arrived. So how do we know this? Let's say current character get position is in range of, let's just say this for now, and let's get that position. So is in range of does not exist. We'll have to create that inside of our position. Currently, we don't have a range, so let's just start by actually having this be an exact match instead of a range, which is misleading, but we'll fix it very soon, I promise. So x is equals to position get x, and y is equal to position get y. All right, so now we've answered if we have arrived. And if we have arrived, then we need to use the controller that we had. And we need to say stop, because the risk is, and we have to make this as well, just create that method inside of our NPC controller. And this will just set all of these to false. So right, false, down, false, left, false. And what could happen if we forget to do this is that maybe we switch states, but we haven't told our controller to stop. So basically that would be like the controller is still holding down the move keys, even though we've stopped calculating where it should go, but it's still holding down the keys because we never told it to release them. So that's what we do here. All right, so this should be fine. Now we need a transition. And let's make a transition like so. A new AI transition. And let's go to a stand. Let's make a lambda implementation here. And we got one too many parentheses, I think. And let's just say that if we have arrived, so if we have arrived, then transition to stand. That's what this is saying. Right now, of course, there are still a couple things we need to do. So from the stand, let's go to a wander. And the last time I said that there's a reason why I'm doing this like so and not. My first thought was actually to instantiate a wander. But since this is called from our constructor, that means that when we create this stand, we come in here and we create a transition, and then maybe we create a wander. But so that means that we create this object, we go into the wander, and we create this. Also, we need to call super. So we create this, and that in turn triggers this transition, and then we create a stand, and then we go back to stand, and then we'd just be in an endless loop, and eventually we would get an exception. So that's why I'm doing it this way instead. And if you have a proposal for a better way to do it, I am all ears. I always want to learn. All right, moving on from that, I sort of lost myself a little. Where were we? We had done this. We went into the stand. We said wander. Good. Now we need to go to the AI manager. Yes, that's why I was talking about it. Now we actually have to make a case for that. So if we do get a wander, then we want our current AI state to be a new wander. And of course we need to return, because in switch, switch, what do you call them? Switch. Well, in switches, it keeps going down. So we need to do this return. All right, so just import that wander, and what else? Let's try that and see if I missed something. All right, it is wandering, and it's looking very funny. As you can see, it has, for some reason, stopped. Let's just see if we can figure out why that was. So if you can see, he's moving very oddly, and there's a reason for that. So when we walk, if we use this controller, and he is now looking for the exact position, but the problem is that in the motion, he has a speed of 2. So if he only needs to go 1 more, but he has a speed of 2, then he'll never reach the exact spot, because he'll always overshoot by 1, and then he'll try to walk back and he'll overshoot by 1, and then he'll turn around and overshoot by 1, and so on and so forth forever. Okay, so we need to add in a range. So let's do that now. And the first thing I'm thinking is we want this range to be set in one place, and we want to be able to get it from all places. So I'm going to start by doing it as a static variable inside of my position class. And I don't know if I want to use as many static variables as I'm starting to, so I might want to do this in another way. But let's start by doing this because it's fast and easy, and this video is going to be long enough as it is. So just make that public static int, and let's call it proximity range. That sounds like a big and scary word, right? And we need to set it to something, so let's set it to 5. All right, so this proximity range. Let's start by going to our controller, and now we need to know if we take the absolute value of x, so no, right, sorry, we also need and. So we only want to press the button if, well, if we are supposed to walk in this direction, but also if let's see, position dot proximity range, and just gonna get a quick look. So first of all, this is y. But the thing is that, so the delta y, the difference between my y positions, it needs to be larger than the proximity range for us to walk. If it isn't larger, then we don't walk, right? So first of all, copy this. This also holds true further down. And then go here, make that an x, and make that an x. So only do the walking if the difference is more than the proximity range for each axis separately. And we're not quite done there. We also have this arrived, and we need to do the same here in our arrived. We have this in range of, right? But this in turn now needs to take in a range in consideration. So let's do this. Let's do the absolute value of x minus position get x. And we want to know if that is less than our range. So let's do position proximity range. And let's do the same for the y. So the absolute value of y minus position get y, and it wants to be less than our position proximity range. Let's try it again and see what happens. All right, he is looking a lot less weird, and he's standing now, and he picked a new, it looks like it's working. Also, just for the fun of it, there's one thing that we can do actually, since our camera can focus on any game object really. We just need to find the game state. See here, we're focusing on player. Let's focus on the NPC instead, and let's see what that looks like. So there is our little NPC, and he is wandering off, and we're following him. So that's a nifty little thing about our implementation of the camera class. And it looks like our wander is actually working. He's picking a new spot. He is walking over there. He's no longer looking like the Mask, or maybe the Tasmanian Devil, which is nice. We probably don't want our little people to look like Tasmanian devils, even though they can be cute. All right, that's it for this video. Thank you so much for following along, and I will see you soon. Hej då!